Hello everyone. Today we're going to be doing a problem that involves some trigonometry identities as well as the unit circle, and we'll review a little bit of solving some quadratic equations and factoring. So this is our original problem up here, so we'll go ahead and jump right in. So the first thing that jumps out to me is this sine squared here. So because I see this, the first thing that jumps into my mind is to use one of these Pythagorean identities, right? So I'm going to go ahead and write that out over here. So I'm going to be using this guy right there. So I know that if I can get this equation in terms of one of these trig functions, that would be a good thing. So if I have this sine squared, well, then I can just take, if I know that sine squared plus cosine squared equals 1, well, then I can just subtract that cosine to get the sine squared by itself. So sine squared theta is going to be the same thing as 1 minus cosine squared, right? So now I can just take this and substitute it into that sine equation. All right, so let's go ahead and do that. I'm going to rewrite it over here. We got 2 times 1 minus cosine squared theta. All right, that's that part substituted in. Then I have plus 3 cosine theta equals 3. Okay, so I'm one step closer. I've gotten everything in terms of one trig function. Now I'm thinking that, okay, well, I've got a term here that has a squared piece on it. I have another one that has an exponent of 1, and then I can get another term here that's not going to have anything attached to it, right? It'll just be the coefficient. So then I'm thinking, okay, well, I'm familiar with equations that look like this: ax squared plus bx plus c, right? Our quadratic form or equations. Okay, so if I know this, I know how to solve those. I just set them equal to 0, right? So let's try to get this up here to try to look like this thing, right? So let's go ahead and do that. So we'll distribute in this 2. So we have 2 minus 2 cosine squared theta plus 3 cosine theta equals 3. Okay, so now we're going to keep going to try to make it look this way. So I'm going to go ahead and subtract 3 and set it equal to 0. So subtract 3 from both sides, I get a negative 1 minus 2 cosine squared theta plus 3 cosine theta equals 0. All right, one more step to get it to look like we want it to. I'm just going to move things around so my squared term is first. So we got negative 2 cosine squared theta plus 3 cosine theta minus 1 equals 0. Okay, so at this point, now I know that I can either factor this or use the quadratic formula. Fortunately, we can factor this thing. So I know that I have to have a negative 2 cosine out front. All right, and I'll kind of write in the shell here. Now, to use a little bit of strategy, I know that my middle term has to be positive, and I know that my end term has to be negative. So one of these signs in here, one has to be positive and one has to be negative. But if I want this 3 here to be positive, well, then whatever I'm multiplying this negative 2 by, I probably want that to be positive as well, because I want my middle term to be more positive. All right, so I'm going to go ahead and put the negative in here and the positive over here. I know that this has to be 1 and this has to be 1, because those are obviously the only two factors of our end term over here. And then I know that the one in the middle, because this is a negative 2 out front, has to just be cosine theta. A little tight there. Okay, and we can check this if we want. I guess we can go ahead and do that. So let's go ahead and make sure that we're right. Because again, this is, I mean, if you get it wrong, you know that all you have to change are these signs here, but let's just make sure. So negative 2 cosine theta times cosine theta, we got negative 2 cosine squared theta. Now this is where I was talking about the signs. So negative 2 times the negative 1 is where that positive comes in. So positive 2 cosine theta. If this wasn't a negative here, and this term ended up being positive, there was no way that we could get back to be a positive 3, right? Okay, so positive 1 times cosine gets us a plus cosine theta, and then we've got our negative 1 at the end, right? We see if we put these two things together, we get the 3 cosine theta in the middle, right? And then we've got our negative 2 cosine theta, cosine squared theta, 3 cosine theta, and negative 1. And we're good to go. Okay, let's get rid of all this. Okay, so again, we know that this is all still set up to equal 0. So let's go ahead and solve it. So negative 2 cosine theta plus 1 equals 0, or cosine theta minus 1 equals 0. Subtract the 1, negative 2 cosine theta equals negative 1, and we know that cosine theta must equal positive 1/2. Alright, let's solve the other one. Cosine theta must equal 1. Alright, so these are our two ending points from that equation. Now, our end goal, right, is to figure out what theta is. So this is where this interval piece comes in, and I'm going to take us over to a unit circle on the next page here. So to rewrite what we know so far, we know that cosine theta equals 1/2, or cosine theta equals 1, right? Okay, so now we need to figure out on the unit circle where we get cosine of theta to equal 1/2 and 1. If you don't have this unit circle in front of you, you can always redraw it. We won't go into the details of how to draw it on this particular video, but if you forget, say which one is which here, which one's sine, which one's cosine, you can always recreate a triangle here. Right, and this is how you would draw it anyway. But so your theta's in there. So if I know that I've got a unit circle here, right, the hypotenuse is going to be 1. If I wanted to figure out what this side down here was, right, that's the x coordinate of that point, and then this side would be the y coordinate of that point. So if I wanted to figure out what x was, well, I'd have to use cosine, right? We got the adjacent and the hypotenuse. So cosine theta would equal your adjacent, which is x, over 1. Oops, over 1, which is the same thing as just x. So I know that cosine theta's got to be x, right? That's our x term, which means that sine has to be the y term. An easy way to remember which one comes first is your cosine is your c in the alphabet, and sine is after. So you know that x coordinate has to be cosine, and this is kind of how you would go about showing that. Now for our video, or our problem here, let's go ahead and erase this stuff here. We care about the interval from negative 2 pi to 0, right? Okay, so on this unit circle, all of these angles here, like this one here, we're going this direction, right? So these are all positive, all right? Positive pi over 6, positive pi over 4, positive pi over 3, positive pi over 2. Okay, so the positive and the negative tell us which direction that we're going on the unit circle. So if I'm looking at negative 2 pi, that tells me that I've got to be going the other way, right? So instead of this being 3 pi over 2, we'll just use kind of a nice benchmark here. I guess we could even, well, that's fine. So 3 pi over 2. So if I go this way, right, that's not positive 3 pi over 2. We're going the same direction in this direction as we would be going that direction to get to pi over 2. So 3 pi over 2 is the same thing as negative pi over 2, right? It's the same separation there as up here. Okay, we're just going in a different direction. All right, so let's look and find all the places where cosine is equal to 1/2. All right, so we got 1 up here. We know that cosine could be 1 as well, and it looks like there, right? That's our only point. And that makes sense, right? Because if we're on a grid, this point is over here at 1, 0, and we know that the x coordinate corresponds to cosine, so that has to be a solution to our problem. All right, so we got 1/2 up here. We've got, and the next place that it shows up is down here at 5π/3, and then we obviously said that one was 1. Okay, so let's take a look at what we've got here. So if I go, remember I'm going in this direction here because we're on negative 2π. Whoops, sorry. iPad software. Okay, so if I want to go that far that direction, that's the same as going π/3 in that direction, and this is where my negative π/3 is. Okay, so instead of being 5π/3, we're going in the negative direction. We know that one of our answers is going to be negative π/3. All right, in the same breath, if we go this way, all the way up there, the distance that we travel, the separation there, is going to be the same as going 5π/3. Oops, too far. Let's use a different color so we're not so jumbled. As going 5π/3. That direction, right? The separation between the rays, or the distance between those two rays, is the exact same. So we find that our other answer would have to be negative 5π/3, right? Because we're going in the negative direction. All right? And then our other answer here, right, where cosine is 1, is going to be 0. All right? So, based on our interval, these are the possible solutions, or excuse me, these are the solutions that satisfy our original equation. Right? So that wraps up this question. Thanks for watching. Hope you have an awesome rest of your day.